Hey, Andre, thanks for joining me today. I just wanted to have a discussion with you around display name deception attacks. This is something that we've been seeing happen more and more, and particularly we've been getting a lot more tickets about this from customers and partners about a particular type of display name deception that is coming out of Gmail. So I just want to get some feedback from you about how this works, what's going on, and realistically what our customers and partners can do to defend themselves against these type of attacks. So if you can you please just give us an overview of what a display name deception attack is?
Hey, Brian. Yeah, sure, man. Thanks for your time too. It's always great chatting to you. So I think what we've naturally been seeing now is we've been seeing a lot more display name impersonation, right? Commonly, it's not really something that we frown upon. We see it all the time, but as we know, realistically, from a DMOC provider perspective, it's not really something that DMOC protects against. Where this attack has changed now is where the threat actors are now actually not only crafting or using the display name, but they're actually adding the email address into that display name field as well. So effectively, when you look at traditional display name attacks, it would be an attack where someone would basically use Sam or use Sasha or someone as an executive level in the business to send email inbound and make employees fall victim to some form of a, hey, I'm busy. Can you quickly send out this proposal? Or can you quickly make this payment? Or can you go and buy these gift cards? To now where it's actually being weaponized against our customers, right? Where they are receiving these emails.
All right, perfect. Thank you for that context. So we actually have an example over here, which we created our own. We're obviously not going to expose our real customer data in these sort of instances. But do you just want to give us an overview of what's actually happening over here? Because at first glance, this is quite strange to actually look at. So who is the actual sender in this instance?
Yeah, so I mean, if you look at where we've indicated here with the blue arrows, you can see that obviously it calls out Sam Hutchinson, it calls out his name, it calls out his email address, and that actual part is the display name. Although it looks like an email address, it's the display name. If you look at the end of that, you'll see there's the samceo1231 at gmail.com, and that's the email address that's used by the threat actor in this case. So what you find is a variety of things happen here. Either these threat actors go and they create these email addresses in Gmail and they basically send these emails, or they compromise an existing Gmail customer and they send these emails out, making it look like this. Now, traditionally, when you look at mail from a mail client perspective, in most mail clients, it only displays the display name when you look at the mail that you've actually received, which makes this look even more believable than it actually is. But when you actually unpack this and you start looking at the headers of these emails, as we've done during investigation over the last few weeks, what's quite bad about this situation is it leverages legitimate Gmail infrastructure to commit or to send these mails and perform these attacks. Meaning when you actually look at the header, the actual from header address that you would see in Outlook or Thunderbird or any mail client that you're looking at that mail in would look like it's actually uh, displaying that it's coming from Sam, but the actual email address is Gmail. And when it leaves Gmail's infrastructure, it's deconsigning on the Gmail domain. It also has basically the Gmail SMTP from or P1 address as Microsoft calls it. So it's passing SPF on a Gmail perspective. And the message ID is a mail.google.com message ID, which means when receiving infrastructure reprocesses these mails, it actually is coming from Gmail's infrastructure. The bad part about it is it makes it very hard for receiving infrastructure to legitimize, is this actually an attack or is this actually the person that's sending this email, which could be a good actor, not a bad actor in this case.
Exactly. And because the email is technically leaving legitimate infrastructure, it is, like you said, authenticating via both SPF and DKIM, and then
Correct.
henceforth it's actually passing DMARC as well. So just quickly to go over again, this first part you're seeing here is the display name to these closed brackets, and then from this bracket here to here is the actual sending address. So for our customers and partners to proactively defend against something like this, what options do they have available to them? Because DMARC is not something that is going to prevent this type of attack from occurring.
I mean, you're 100% spot on when you say that, Brian. And I mean, like, if we look at it from an industry perspective, we always say to customers, DMARC is part of that cybersecurity journey, right? But we always advise them that there are other parts of the cybersecurity journey that they need to look at. And the two examples that we've highlighted here, I think, are the best kind of advances that you can take to help make this more evident or to help users detect this and not act on it, right? And the first part is obviously user enablement or user awareness training, right? So your typical user awareness training where you would train users to be able to identify more sophisticated attacks, like display name impersonation, like, for instance, where emails come from people with certain instructions, which are not generally instructions that you would receive from people, right, in that space. And then the second part that I think is quite important there is looking at inbound security. As much as DMARC helps you secure what you send as a business and authenticate what you send as a business, inbound security is just as vital in the sense that you need to have some form of technology that has advanced filtering or advanced detection capabilities, like an ETP, like an EOP, like an ATP, some form of a SEG technology that can in some way uh, calculate user behavior. And in some of these technologies, it also has the capability of determining common addresses that communicate with each other or domains that communicate with each other based on the learning that it does with user behavior and how users communicate in general.
Exactly. So a lot of the newer solutions out there, the API-based
Correct.
solutions which use AI and those sort of technologies. So I just want to touch on the two key points that you discussed there. Number one is your human firewall element, because we all know the weakest link in any business is the end user itself in terms of cybersecurity. And cybersecurity is ideally everybody's responsibility within inside of an organization. And
Correct.
then you also touched on inbound email filtering, whereas DMARC primarily focuses on your outbound and authenticating emails that your infrastructure sends. It is also very important to not neglect that inbound filtering of emails coming into your infrastructure. All right,
100% correct.
perfect. Thanks, Andre. Appreciate your time as always. Have a good
All
rest of your
right.
day.
You too.